Welcome to Lesson 8, Software Development Security, End of Lesson Exam Review. Now this was a fairly short lesson, but with a lot of information. We were totally focused on software development security. We started out talking about the software development lifecycle, the traditional model, and the concerns we have in the traditional model because it doesn't address security at all stages. So then we looked at the Microsoft Security Development Lifecycle, SDL, and we went through all of the phases so that we could understand how right from the very beginning, matter of fact, even before we get to a requirements phase, starting earlier with training, how we can ensure that we integrate security into the entire lifecycle, requirement stage, all the way through post-deployment and maintenance. We then looked at various development approaches, models, tools, and testing. We looked at capability maturity models, we looked at various project models, we looked at tools that can be used, and we looked at 6 different types of tests that can be applied. We then started looking at source code issues, including injections, buffer overflows, covert channels, memory and code reuse, time of use, time of check, race conditions, and maintenance hooks or backdoors. In the next lesson, we looked at database security, and we approached database security from the perspective of confidentiality, integrity, availability, and privacy. And lastly, we looked at the security of acquired software, and we did a walkthrough of the process of acquiring software, which also allowed us to revisit requirements definitions, doing risk assessments, looking at risk management, testing, user training, and then ongoing support and maintenance. So all of these areas relate to software development security and are important for a CISSP to understand whether you're with an organization that develops software or acquires software, or in most cases, a combination of both. So let's look at 5 questions. Again, the questions relate back to these lessons, but we're also going to look at them in terms of how you should best approach the questions during your exam. So question 1. Core security training for developers and programmers should include all of the following except. Now, if you recall from our Microsoft Security Development Lifecycle, core security training is a type of training that your programmers, your developers, your QC people, your interface testing folks get at the beginning of a process. So before they even start doing requirements or development, this is the core training that they all should have. So our choices are threat modeling, secure coding, privacy best practices, and quantitative analysis. Remember, threat modeling is determining what the viable threats are. Secure coding certainly is learning our best practices for secure coding. Privacy best practices is understanding privacy implications. And then a quantitative analysis is doing an analysis based on asset value, so a monetary analysis. So if we think about what our core security for trainers and programmers should be, well, we certainly want them to know about threats. We definitely want them to know about secure coding. Because they need to be concerned about privacy and security, we also want them to know about privacy and security best practices, so C, privacy best practices. D, quantitative analysis. We're probably not going to be asking our developers and programmers for doing a risk assessment using quantitative techniques. So the one we're going to choose as our correct answer will be D, a quantitative analysis. That our core security training for developers should include threat modeling, secure coding, and privacy practices. Now, if you're struggling with this one, you wanted to make sure that you were reading the question that said all of the following except, and then you really want to look at what's the one that's not like the other and the one that's not applicable to the subject. In this case, our subjects were developers and programmers. Question 2. Which of the following statements is not true about DevOps? And we looked at DevOps as a development methodology. A DevOps approach model incorporates a sequential waterfall model. Remember, sequential waterfall is that you do one step at a time. You complete that step in its entirety before you go on to the next. A DevOps approach stresses communication, collaboration, and automation. A DevOps approach aims to minimize probability of failure, cost, and risk. And a DevOps approach aims to maximize efficiency, predictability, and security. So if you're looking at this, and again, maybe you don't quite remember what DevOps does, but you do know it's a model, right? And it came from the Department of Defense, and it is combined with Agile, but perhaps you don't even recall all of those. Start looking at what answers seem to go together. We've got DevOps approach stresses communication, collaboration, automation, which may minimize probability of failure, cost, and risk, and maximize efficiency, predictability, and security. So the outlier here would be incorporates a sequential waterfall model. And it would be important to know what a waterfall model here is, or to be able to define sequential, again, which is one step at a time, very isolated. So the statement that's not going to be true is A, that it incorporates a sequential waterfall model. Question 3, this type of flaw is prevalent in legacy software. So here we're being told it's a flaw, legacy software, and often targets data-driven applications and databases. So we're going to be looking for a flaw prevalent in legacy software, often targeting data-driven applications and databases. Our options are injection, a buffer overflow, cross-site scripting, and directory traversal. Now, injection is when we inject instructions, malicious instructions, that the processor will execute. We did talk about the fact that that is prevalent in legacy software, and we discussed that one of its uses is going to be in databases. And if you sort of took this to the next step and thought, well, where have I heard about injection a lot? Well, SQL injection. So now we've got to tie in between injection and a database, legacy software, and a flaw. Now that is going to be the right answer, but let's look through the others and see what you might think about them. The next one is a buffer overflow. Right? In a buffer overflow, that's where we're going to be overflowing the memory buffer. Right? So we're not hearing anything in our question about a memory buffer. Cross-site scripting is where we're going to inject code, potentially in a database or in a website, that then comes down and executes in a local browser. But there's nothing in our question about websites, about web applications, or about local browsers. And directory traversal is when we can move from one directory to another because permissions haven't been set correctly. But again, nothing in our description really matches that. So hopefully you knew that the type of flaw right off the bat was injection. But if not, you can both look for keywords and then think through your other answers and say, is there anything in the question that really relates back to these other answers? All right, so I want you to do this one with me and see if you can fill in the blanks as we go along. Blank testing should be done after an update or a patch is applied to verify the changes didn't disrupt functionality. Blank testing is done to identify weaknesses and flaws, or blank testing is done to verify that a product meets design specification. Now maybe you got all three, but I'm pretty convinced that you probably got the middle one. Blank testing is done to identify weaknesses and flaws. That would be vulnerability testing. So assuming that you've gotten that one, we're going to keep that in mind as we're looking through our answers. So our four answers here are validation, unit, and acceptance, regression, vulnerability, and validation, assurance, vulnerability, and validation, and regression, vulnerability, and acceptance. So let's go through and see what we can do. We don't like A, right, because we said we needed vulnerability testing to be in there. That's what we think our middle one is. So it's not going to be validation testing is done after an update, unit testing is done to identify weaknesses, or acceptance testing is done to verify the product meets design specifications. So we're going to get rid of that one. The next one, regression testing should be done after an update or a patch is applied. Vulnerability testing is done to identify weaknesses and flaws. And validation testing is done to verify that the product meets design specification. That one's looking good. But let's keep going. The next one is assurance testing should be done. Now, assurance was not one of our testing models for software, so that's not going to be true. We're going to get rid of that one right away. All right, so now let's go to our last one. Regression testing should be done after an update or a patch is applied to ensure the changes didn't disrupt functionality. Well, that is regression testing, and we did have that in both B and D. Those are our two remaining answers. That's good. Vulnerability testing is done to identify weaknesses and flaws. We like that answer, and we do have it in both B and D. Good, we keep on going. Now we've got blank testing is done to verify that a product meets design specification. So this is where you're going to have to choose between validation testing and acceptance testing. And if you remember, validation testing is when we do testing to verify a product meets design specification. Acceptance testing is when the user accepts the application as it's meeting its usability standards. So acceptance doesn't work here. That's going to bring us to B, which is regression, vulnerability, and validation. Our last question, question 5. Database consistency means that blank is described in the blank model. All right, let's look at our answers. That transactions are correct across all instances, BIBA. That transactions cannot be rolled back, Bella Padula. That transactions cannot be rolled back, Brewer-Nash. And that transactions are correct across all instances, Clark-Wilson. So you have two ways to approach this question. Either you know what database consistency means, or you remember the model. So if you think about database consistency, we have two choices here. The transactions are correct across all instances, or the transactions cannot be rolled back. Okay? Now consistency, if you just think about the word, again, means that it's going to be correct or the same in multiple places. So we're going to get rid of our rolled back. So now we like A and D, that the transactions are correct across all instances. And now you have to go back and think about the models. Is it the BIBA model, or is it going to be the Clark-Wilson? Now both BIBA and Clark-Wilson models were integrity models, but BIBA was that we could have no read down, no write up. Clark-Wilson was our access triple. We needed to prevent unauthorized users from making modification. We needed to prevent authorized users from making improper modifications, and we needed to maintain internal and external consistency. So we're going to like our definition right here of database consistency, and our Clark-Wilson model does describe consistency. So D, transactions correct across all instances, and Clark-Wilson. That's going to be your correct answer. So thanks for joining me for this lesson review, and I look forward to seeing you again in Lesson 9.